Hello students, myself Raghavendra Hegde. Welcome to my channel RH Chemistry. So today we will discuss about structure of atom, Super 10 series, 10 questions we are going to discuss. So the first question is, the energies of E1 and E2 of two radiations are given. The relation between their wavelength lambda 1 and lambda 2 they are asking. So option is given like this. So then what to think about this question? See, when wavelength is asked, energy is given, then use the formula E is equal to h nu is equal to hc by lambda. Correct? So hc by lambda. Energy and lambda is inversely related. H and c is constant. Hence I can write this as E1 divided by E2 is equal to, remember, lambda 2 divided by lambda 1. Because these two are inversely related, hence I can write this particular relationship. Then they are asking lambda 1 by lambda 2, right? So lambda 1 divided by lambda 2 is equal to, so E2 divided by E1. So what is the value of E2? That is, E2 is 50 electron volt. 50 electron volt divided by, so in this particular case, this should be 25, 2.5, it is not 2.5, it is 25 electron volt. Right? So 50 divided by, in this case, 25 electron volt. So is equal to, so 2 divided by 1. So hence I can write the relationship as lambda 1 is equal to 2 into lambda 2. Hence lambda 1 is equal to lambda 2, which is the answer? So answer C is the correct one. Yes, second one. The angular momentum of electron in 3D orbital is. So before that I will tell you. So always remember this MVR is equal to NH by 2 pi, what you learn in Bohr's theory. Bohr's theory. This is the angular momentum of electron in orbit, remember. This is in orbit. But what they are asking? Orbital. Correct? So MVR of orbital formula is, remember, so root of L into L plus 1 H divided by 2 pi. Root of L into L plus 1 H divided by 2 pi. So in this particular case, what is L value? Always remember L is equal to 0 for S orbital, L is equal to 1 for P, L is equal to 2 for D, L is equal to 3 for F orbital. So hence remember here D orbital is given, right? D means L is equal to 2. So substitute the answer. So this is also written as capital L, MVR in the case of orbital. So root of 2 into 2 plus 1 into H by 2 pi. So you are going to get this as root 6 H by 2 pi. So we know that root 6 I can write it as root 3 into root 2. Right? Divided by 2 can be written as root 2 into root 2 H by pi. So that you are going to get root 2 get cancelled. So answer for this question will be root 3 divided by root 2 H by pi. But this particular equation is very important. Remember, root 3 by root 2 H by pi. So answer is there. That is C. So this is the second question in this particular case. Yes. Now we will discuss about third question. Third and fourth question. So we will see. Yes. Now in case of the question number 3. The principal quantum number n is equal to 6. The correct order of filling of electrons will be. Remember, this is according to which principle? Aufbau principle. Remember, Aufbau principle. According to Aufbau principle, what should be filled? So always remember, according to Aufbau principle, when you write, very easily I will write that 1s, so that 2s, 3s, 4s, 5s, 6s, like that. So 2p, 3p, 4p, 5p, 6p. So 3d, 4d, 5d. So 4f, 5f. Right? Now, in this particular case, remember, first we will start with 1s. So then 2s, then 2p. Right? 3s, then 3p, then 4s. After 4s, remember, you will write 3d. So then 4p, 5p. So 4p ಆದ್ಮೇಲೆ 5s. So after that we will write 4d, then 5p, then 6s, right? So 6 is given, correct? So ns is equal to 6. After 6 what you will do? You will fill 4f. If 6 is equal to n is equal to 6, 4 means n minus 2. So n minus 2f, these two options left. So after that what you will do? You are going to fill in this particular case D. Correct? You are going to fill in this particular case, that is D, which means this should be the correct answer. This should be the correct answer. Remember, very important, Aufbau principle, energy level diagram you have to draw so that you can easily get what is the answer for such type of question in any exam. This is about question number 3. Yes, question number 4. In case of the question number 4, what is given? You see, the energy of electron in the first Bohr orbit of hydrogen atom is given. So, minus 13.6 electron volt. The energy of electron in the first excited state of Li2 plus will be. So, in such question, what we have to do? So, here, write the formula. Energy formula you have to write. So, energy formula is equal to minus RH. So, in this case, Z square divided by N square. Z is equal to atomic number. So here RH value in terms of electron volt they are asking, right? So RH value in terms of electron volt you are going to get minus 13.6 only. So minus 13.6 electron volt into Z for lithium. Lithium atomic number is 3. So 3 square divided by. So they are asking energy of the first excited state. Whatever first excited state is given, the mistake we will do it here only. First excited state means n is equal to 1 we will take. But remember, first excited state n is equal to 2 here. So 2 square. Right? So you are going to get minus 13.6 into 9 divided by 4. So shortcut, we require approximate answer, right? So 4 ones are 4, 3 is a 12. 13.6 is there, so 3.1 like that you will get. So 9 3 is a, so 27. So 27. So here you have taken 13.6. It should be more than 27. So more than 27, answer should be in minus. So if you calculate the answer for this question, you are going to get exact this answer. 27 means you cannot select this answer because remember 13.6 I have taken 4 3s are 12. So that if you calculate without calculator, approximately you will get minus 30.6 electron volt only. So the answer for this particular question is B. So when such question is given, remember formula. So formula should be perfect. In that case, all those formula list you have to make, you have to practice those formula for any competitive exam. It is very helpful. So this is about question number 4. Yes, now we will discuss about question number 5. Very important question. So in JEE exam also it was asked. So remember, the question is the angular momentum of an electron in Bohr orbit of He plus C is given. So orbit angular momentum. First I will write that. Orbit angular momentum is equal to MVR is equal to NH by 2 pi. So it is given it as 3.16 into 10 to the power minus 34. Unit not necessary to write while solving in the this numericals. What is the wave number in the terms of Rydberg's constant? Wave number nu bar they are asking in terms of Rydberg's constant. So to calculate that we have another formula, right? Nu bar is equal to so RH into 1 by n1 square minus 1 by n2 square into once again Z square. Z is equal to atomic number. So Rydberg's constant, in terms of Rydberg's constant are spectral line emitted when electron falls from this level to the first excited state. This level how to calculate? This is very important. This level, then if you get this level, then you can easily think about first excited state. Right? So this level is nothing but n value. Whatever this level it is there, what is that? N value. ಅಂದ್ರೆ MVR is equal to NH by 2 pi ದಲ್ಲಿ ಇರುವಂತ n ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. If this n value whatever we will get. So remember, very important. So whatever the n value you are going to obtain in this particular case. So 1 less than that should be n1. This is n2. Directly we will get n2. 1 less than that should be n1. Yes, now we will calculate n value now. Then we substitute here. So n is equal to, in this case, 3.16 into 10 to the power minus 34. So what I will do? Into pi value I will take it here. 2 pi value here I will take. So 2 into 3.142, right? 2 into 3.142. So divided by, you are going to get, so h value will take it in the denominator, 6.6 into 10 to the power minus 34. Very important h value you have to remember. So remember, minus 34 get cancelled. So then what is left? See what is left. See here in this particular case, 3 ones are 3 twos are 6. So 2 ones are 2 ones are get cancelled. Answer is nearest to 3.16 means what I can take? So n is equal to 3 I can take here. So if n is equal to 3, here you can see if n is equal to 3, r into 1 by, if I told if n is equal to 3, this is nothing but n2. n1 should be 1, sorry 2, n1 should be 2. First excited state is nothing but 2 here. So 1 by 2 square minus 1 by 3 square into z square. This is hydrogen atom, right? Emitted falls from this to first excited state. So it is hydrogen atom. So we will consider it as z is equal to 1 only. Then here 1 by 2 square minus 1 by 3 square. So you can calculate. So 1 by 4 minus 1 by 9, right? So 2 square minus 3 square you got. Then so r value here in this particular case, sorry here 1 square, here helium is given, remember. So it should be 2 square. Z for helium, helium is Z is equal to 2. So 2 square means here you can write 4. So is equal to r into 9 minus 5 means 5 by 36 you got 5 by 36 into 4. So 4 ones are 4 nines are. So you are going to get the answer 5 divided by 9r. So 5 divided by 9r is nothing but option B here. Very important. In the such type of problem, what is given, you write it correctly. What to calculate, you write it correctly, so that half of the work is done in such questions. Remember, very important, this formula and this formula you have to read. This is about question number 5. So let us see question number 6 and question number 7. Yes, 6th question and 7th question we will see. 6th question is see, in which of the following transition will be wavelength will be minimum. So the n6 is equal to 4, n4 is equal to 3, 3 is equal to 1, 2 to 1 it is given. So remember, energy if it is more, lambda will be less. Because of this formula, lambda is equal to h nu is equal to hc by lambda. In which case energy is more. So remember, this is the one series which is responsible for n is equal to 4. So in series what we know? Lyman series, we know that Lyman series, Balmer series, Paschen series and bracket series. Correct? So in this particular case, here Lyman series n is equal to, n1 is equal to how much? 1. n1 is equal to 2. n1 is equal to 3. n1 is equal to 4. So like that. So 1, 2, 3, 4. Now the shortcut is, in this case, these two should not be the answer. Because a Lyman series obtained in UV region is the highest energy region. Highest energy, lesser is the wavelength. Now the question is whether this is the answer or this is the answer. For that, we will consider this particular formula, Rydberg's formula. In case of the Rydberg's formula, remember 1 by lambda minimum is equal to, that is 1 by lambda is equal to RH into Z square into 1 by N1 square minus 1 by N2 square. How to calculate this? Remember, if this is minimum, if this we require minimum, what should be this answer? This minus 1 by N1 N2 square, remember. So if this minimum, or you can write it like this, lambda bar. So if this is minimum, remember, lambda bar will be maximum because it is, nu bar will be maximum. This is inversely related. This nu bar is maximum. What should be this value? Minimum. If that minus 1 by N2 square should be minimum, then N2 square should be maximum. Always remember the shortcut for this. So if lambda nu bar maximum we require or nu bar minimum we require, if nu bar maximum require, N2 should be infinity. So which means we can say high, nu bar minimum is equal to N2 should be less. Here lambda minimum we want means nu bar maximum means N2 should be high. So N2 should be maximum. Out of these two, in which case N2 is more? N2 is more in this C case, right? C case, because N2 is nothing but this only. Higher excited state to lower state, which means N2 is equal to 3 to 1 should be the answer. So 3 to 1 should be the answer. So remember, out of these four, out of these two, which one is the answer? For that you have to go for this formula. So Rydberg's formula dalli very important andre, if lambda minimum if you want, N2 should be maximum. Very important case. Out of these two, which is maximum? So this is maximum. Hence the answer is C in this particular case. Right. 7th question we'll see. 7th question. The quantum number of 4 electrons are given. So quantum numbers of these 4 electrons are given. Right. Correct order of their increasing energy will be. So to order this, remember, we need N plus L value. So see N plus L value. If the orbital with N plus L value more, then it will have more energy. So now you will see N plus L value, I will write it here. N plus L value, I will write it here. 4 plus 2. What is the answer? So 6 here. N plus L. 3 plus 2. That is 5 here. 4 plus 1. That is 5 here. 3 plus 1. That is 4 here. Which means N plus L value maximum means maximum energy. Right? So N first one should be the maximum energy. So these two options left. Right? So these two options left in this case. Now 1 or 2. Now minimum is which one? Minimum is in both the case 4 only. Minimum is 4 only, right? So 4 only. But second highest. See, if both, see N plus L value, highest, higher energy. If N plus L value is same, if N plus L value is equal to same, then remember, higher N value, higher energy. Two statement we will discuss in case of the N plus L rule, correct? So N plus L value, if it is same, higher the N value, higher is the energy. Because of that reason, remember, answer should be, next higher than value is to 3. So option should be B is the correct answer in this case. B is the correct answer because N plus L value check made. So it is 6, 5, 5, 4. 6 is maximum. So 1 should be more. Then 4 should be minimum. But out of this, which is more? So 3 is more because N value is more for this case. So this should be the 7th question. The answer is B. Yes. Let us see 8th question. Very important question. 8th question which was asked in last JEE exam. Remember that. So now, for any given series, a spectral line of atomic hydrogen, let nu delta and change in the nu bar. So delta nu bar is equal to lambda nu bar max minus nu bar minimum. Be the difference in maximum and minimum frequencies. Be the difference in the maximum and minimum frequencies. Then ratio of lambda nu bar Lyman series divided by nu bar of Balmer series is. So what they have given? Delta nu bar they want. That is equal to nu bar maximum is minus nu bar minimum. So maximum and minimum frequencies. Then nu bar of Lyman series to nu bar of Balmer series they are asking. So for this, once again we are going to use the formula. Nu bar is equal to R into, so 1 by N1 square minus 1 by N2 square. So here hydrogen is given, hence I will not write Z square. Z square you can write, Z is equal to 1 you will get. Right? So first what you have to do? So see here, we require nu bar is equal to. So what we want is equal to nu bar maximum minus nu bar minimum, right? So first we calculate nu bar of Lyman series. First we calculate nu bar of Lyman series. Then we calculate nu bar of Balmer series. Then we calculate, so change in nu bar, that is here we require delta nu bar, right? So delta nu bar of Balmer series we calculate, and change in delta nu bar of this Lyman series we calculate, that is nu bar of maximum minus nu bar of minimum is equal to, here also nu bar of maximum minus nu bar of minimum. So then we calculate this, the nu bar of Lyman series divided by nu bar of Balmer series. Lyman series divided by Balmer series. Fine. So first we calculate this. Now you can see, I told this, nu bar maximum if you required, what should be the N2 value? N2 value should be the minimum, remember. Right? Sorry, maximum. N2 value should be maximum. So always remember, so nu bar maximum you want, then N2 should be the infinity value. Right? If nu bar minimum we required, N2 should be N1 plus 1. So write N1 plus 1. Lyman series, remember Lyman series N1 is equal to 1. So Balmer series N1 is equal to 2. So remember that. Now you will see, in this particular case, nu bar maximum, we write the formula. So we'll write the formula. R will keep it as it is because later R is going to get cancelled. Right? So R into 1 divided by 1 square, that is N1 square. N1 is equal to 1 minus nu bar minimum means, minus maximum only 1 by N2 square is how much? Infinity square. Minus of nu bar minimum. Nu bar minimum means R into 1 by 1 square minus 1 by 2 square. 1 by 2 square is equal to, what is the answer you got? So here 1 by infinity is equal to 0. So R minus R, here 4 minus 1, 3 by 4 will get, right? 2 2s are 4. So 1 by 1, 1 minus 1 by 4 is equal to 3 by 4. So R into 3 divided by 4 is equal to, I can write, R is common, you remove it out, so that you are going to end up with, so in this particular case 1 by 4, correct? So answer is R by 4. So R by 4. So this Lyman series R by 4 I am going to take. R by 4. Correct? So fine. Now, so we required here this one, right? So delta of nu bar like this. I think you understood this. Now we'll come to Balmer series. In case of the Balmer series, you see, nu bar maximum is N2 is infinity, N1 is 2. So R into 1 by 2 square minus 1 by infinity square minus of lambda bar minimum, nu bar minimum, that is R into 1 by, so minimum means here once again 2 square minus 1 by, so next higher number is N1 plus 1. N1 plus 1 means 3. So 1 by 3 square. 1 by 3 square. Now you simplify this particular thing. So when we simplify this, see, if you simplify this, what happens? Now you are going to get, so is equal to 0. Is equal to 0 means, I will write it here, 1 by 4. So R divided by 4 minus here 1 by 4 minus 1 by 9. So we will simplify this. 1 by 4 minus 1 by 9 is equal to how much you got? 5 divided by 36. Correct? 5 divided by 36. So 5R divided by 36 you got. Correct? Then you remove it simple R out. When you remove that common R out, you are going to get 1 by 4 minus 5 divided by 36. 1 by 4 minus 5 divided by 36. So 1 by 4 minus 5 divided by 36 is equal to, now you simplify this. So you are going to get R divided by 9. Because 36 minus 20. So 16 divided by 36. So 36 into 4. R divided by 9 you are going to get. So I will write it as R divided by 9. So then R get cancelled. Then what should be the answer for this? Denominator of the denominator goes to numerator. So answer should be 9 by 4. Answer should be 9 by 4. So 9 is to 4 should be the answer. So let me repeat once again. So nu bar maximum. So delta nu bar is equal to nu bar maximum minus nu bar minimum. They want delta nu bar of Lyman divided by delta nu bar of Balmer series. How much? So nu bar maximum, very important. If this is maximum, this should be maximum. If this is minimum, N2 should be minimum. Nu bar maximum is N2 is equal to infinity. Nu bar minimum is N2 is equal to N1 plus 1. So hence, first you calculate delta nu bar of Lyman series, then Balmer series, then divide that. So nu bar maximum here only I have separately you can calculate and substitute. Instead of that you can do it here. Simplification is required. Then you are going to get 9 by 4 is the answer. So this is 8th question. So answer. So next we'll see ninth question in this particular case. Here I have considered a statement type of question. See, here the question is which one is wrong statement? The uncertainty principle is delta T into delta E more than or equal to H by 4 pi. So one by one statement we will see. So statement A. So when we will call it as uncertainty principle, first time when we see, we'll think that this should be the answer because it is wrong. Because we think that we learnt delta X into delta P more than or equal to H by 4 pi. Or we have learnt delta X into delta V more than or equal to H by 4 pi m. These two formulas we will learn in generally theory classes. But remember one thing, this is also correct statement. So time and energy you cannot calculate simultaneously. Time and energy you cannot calculate simultaneously. So this is also correct. Remember that. So delta X, delta P and delta T into delta E more than or equal to H by 4 pi is also correct statement for Heisenberg's uncertainty principle. Hence, this is the correct statement. B. Half-filled and completely filled orbitals are more stable due to greater exchange energy and greater symmetry. That we know. Half-filled orbitals are more stable. Completely filled orbitals are because of these two reasons only. It is also correct statement. De Broglie's wavelength. De Broglie's wavelength formula you know. Lambda is equal to H by mv. So this answer is also correct. But very important, which is wrong statement? The energy of 2s orbital is less than the 2p orbital in case of hydrogen-like atom. It is wrong statement. Then what is correct? So for hydrogen or hydrogen-like species, for hydrogen or hydrogen-like species, Aufbau principle is not like other atoms. Remember, for other atoms, what we'll consider? 1s less than 2s less than 2p less than 3s less than 3p less than 4s less than 3d less than 4p, like that it continue according to Aufbau principle. But very important point is that hydrogen or hydrogen-like atom, only one electron is present. This is a single electron system. Because of this reason, it is 1s less than 2s equal to 2p less than 3s equal to 3p equal to 3d less than 4s equal to 4p equal to 4d equal to 4f. So always remember the same orbit, whatever 2s 2p is there, 3s 3p 3d is there, energy will be same. Energy will be same. That is very important concept you have to remember for this hydrogen or hydrogen-like atoms. This should be the order. So for other atom, this should be the order. Because of that reason, this statement is the correct answer. In this case, wrong statement. So this is the question number 9. Then we will see question number 10. The question number 10 is, remember, what is the work function of the metal? What is the work function of the metal? If the light of wavelength 4000 angstrom unit generate photoelectron of velocity 6 in 10 to the power 5 meter per second from it. So, very important, very simple formula, simple question. So, what to think? So, whenever the question is given, you think about the basic of that, right? Photoelectric effect they are talking about, which means kinetic energy is equal to h nu minus h nu naught, correct? Work function is given. They are asking work function. What is work function? This is nothing but work function. So work function is h nu naught, which means you have to calculate h nu naught. So then wavelength is given. That is nu is equal to c by lambda, right? C by lambda. So this wavelength is given. C we know that. Then we can substitute it here. Now photoelectron velocity is given. Kinetic energy is nothing but what? Kinetic energy is equal to half mv square. Velocity is given. And they are telling about electron. Right? When it is electron, remember, so electron mass is equal to 9 into 10 to the power minus 31 kg. So substitute here. So I will write this as half mv square is equal to h nu minus h nu naught. I required h nu naught, so I will write it here. H nu naught is equal to h nu minus h nu, you are going to get minus half mv square. Now, this h nu I can write it as hc by lambda minus half into mv square. Now we substitute all the values. So you are going to get it as h 6.6 into 10 to the power minus 34, c value 3 into 10 to the power 8 divided by lambda value is how much? 4000 angstrom unit. 4000 extra minute, I will write it as 4 into 10 to the power 3 into 10 to the power minus 10. So that I can write it as 4 into 10 to the power minus 7. So 4 into 10 to the power minus 7 minus half into mass is 9 into 10 to the power minus 31 into v square. V is how much? Velocity 6 into 10 to the power 5 square. 5 square. Right? So I will continue here. Now you can see here 10 to the power we will write it first. H nu naught is equal to 10 to the power we will write into 10 to the power minus 34 plus 8 means minus 26. Minus 26 plus 7 denominator to numerator plus it become plus 7 is equal to 10 to the power minus 19. 10 to the power minus 19 minus here also I will write the 10 to the power first. 5 to the 10 minus 31 plus 10. How much? Minus 31 plus 10 minus 21. So 10 to the power minus 21. Then you substitute, simplify this. So now if you simplify this particular 6.6 into 3 divided by 4. So if you simplify this, you are going to get almost 3.4. 3.4 bartada. So because 6.6 into 3 is how much? 20 divided by 4. Right? 6.6 into 3. That is 20. Correct? So you are going to get 19 point something you will get. So 20. So 20 means 4. So 4 5s are 20. So you are going to get 5 into 10 to the power minus 19. 5 into 10 to the power minus 19 because 6.6 into 3 divided by 4. Here 6 6 are 36. Correct? 6 square means 36. So 36 divided by 2. How much? 18. Right? 18. So 18 9s are. How much you got? So 162. 162 into 10 to the power minus 21. So 6 2s are is 36. So 2 1s are 2 18. 18 into 9 is 162. So I will write it like this. I can write this as 5 into 10 to the power minus 19. Minus you convert this into minus 19. 1.62 into 10 to the power minus 19. Correct? So now in this particular case 10 to the power minus 19 is common. I will remove it out. When I remove it out, remember you are going to get almost 5 minus 1.6 is how much? 3.4. So 5 minus 1.6 is 3.4. Then it is in case of, remember, joule. Joule. Now the conversion factor. Conversion factor is which one? 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So then joule converted into electron volt means what you have to do? In this particular case. So 3.4 divided by 1.6 into 10 to the power minus 19 divided by 10 to the power minus 19 get cancelled. 3.4 by 1.6 is how much? So 34 divided by 16. So is equal to 16 2s are 32. So 2.1 should be the answer. Right? 2.1 should be the answer. So this is the answer for this question. So this is about super 10 questions in case of the structure of atom. So in the next video I will come up with the second PUC, some other chapter. Till then, thank you. Have a nice day.